Hello, 9 CBSE का? Yes. वही बनेगा? Yes, ma'am. Yeah. Okay, so I'll begin by chapter A. Of science, which is motion. Right? So, so your science portion is combined, like it has physics, chemistry, all these portions and biology chapters. So today I'll be taking a chapter from physics, which is motion. So let's begin by defining motion. Exactly. So how do we put it in terms of? So basically, to define motion, we have to have, like you said, something moves from position A to position B. Let us. So, so with respect to some reference position, let us say if it is some coordinate, say some origin, right? Yes. So let us say a body moves from position A to position B in a given time, then we say it is moving. Its position is changing with time, right? So how do we define it? A body is said to be in motion when its position changes with respect to some reference position. Okay. With respect to some reference position, okay, say origin. Like when I say I move 1 kilometer, right? So I moved 1 kilometer from where? That's very important. So that is a reference. Right now, so I cannot say I moved 1 kilometer. That information is not complete. So I moved 1 kilometer from where? That also I need. Okay. So first to write this. matter in our surrounding, which is in chemistry, right? Yeah, so we're starting. So you have a different teacher who will teach you matter in your surrounding. In your school or here you are talking? Okay. So here also, a different teacher will start your chemistry portion. So he would be probably will start with that. Got it. So I think 2-3 teachers will be teaching you science. Reference point or position. So all the distance to the right of the origin, like this will become positive. All the distances traveled to the left will become negative. So this is the sign convention. So towards right. It's positive. This is towards left. Can I explain what? Origin is the reference point. Like from where we are measuring the distance. For example, let us say I want to measure the length of this cable top. So I will have to measure the length from the beginning, right? That beginning will be the origin. And from here I will measure, so it is, let us say 1.25 meters, 125 centimeters or 1.25. So I need a reference point. Yeah. Origin means originate or starting point. So start of the motion. So in the given example, what is my origin? A. Yes, we got it. To get the sense of direction, which side are you moving? Right. So very soon you will have concept of distance and displacement. Right. So suppose this object is man, right? So man can walk in this direction or in this direction. So how do I differentiate? So when it's going from left to right, this is positive. And when it's going from right to left, then it is negative. Okay, the sense of direction. Now, motion is actually relative in nature. Right?
What does this mean?
So this is what we'll understand. So let us say a group of 4 people are traveling in a car. So the fellow passenger in the car, they are at rest with respect to each other. Right? Suppose
Father is going for the man is not good.
yeah, so that's what. Right?
Yeah.
So we have like one person sitting here, and the other person is sitting here. Okay. So he doesn't see this guy moving with respect to him, right? Only the car is moving. Right? Even the car is at rest with respect to the bus. They are moving, right? But on the road, if somebody is standing here, he sees that both the buses are going away from him. So for person A, let's say name this as B and C. For A, B and C are going away from him. So they are moving. So for A, B and C are in motion. Right? But B and C are at rest with respect to each other. So motion is a relative concept. It could mean different things to different observers. So it depends on who is watching the motion. Got it? Like when we are on planet Earth in this classroom, we are sitting and taking this class. Right? If somebody could watch us from moon, then we are moving. But in the class we are standing. Right? So the motion is different for different observers. So it's not a absolute thing, it is a relative concept.
So the case is the
Earth is also in motion, it's revolving around sun. But
yeah.
all the buildings are intact. You know, they are all moving along with Earth, right? Buildings are like sitting passengers on Earth. Car is like planet Earth. All the buildings, all the belongings of Earth are like these passengers. The whole Earth is a spaceship. So we are all moving with the Earth. But with respect to each other, the buildings are stationary. So when some observer sees them from outside Earth, then the Earth is moving. But not from the plane, because plane is also in the gravitational field of Earth. So although it is moving relative to the surface of Earth, right? Like this car is moving with respect to the Earth, but this car also sees that the buildings are not moving. Just like that. Okay. So are you with me? Are you understanding what I tried to do? So this is in short the concept of motion. Can I erase it?
Yeah, except for the point A.
Yeah. So physics is very conceptual. So once you understand the concepts, you don't have to memorize anything. It will be like part of your personality, right? So okay, so I think it's in the attendance sheet. It's UDAY. My name is UDAY. Yeah. So in your attendance sheet and timetable you get. every teacher's name is like my name appears full today, but for some whose names are long, it will be only acronym MJ. What about Makia? I think it is maths, right?
Yeah.
So it is MJ, right? उसका सही क्या है? अच्छा, you have another class after this?
Yeah.
This is what, right? What for A, B and C are in motion, but B and C are at rest with respect to each other. So now I am going to discuss about concept of distance and displacement. Displacement. Concept of distance and displacement. So consider 2 points. Let us say this is point A and this is point B. Right? Let us say this is Mumbai and this is Pune. Let us say. Right? So I can go to Pune like this. Say some city, Nasik. Okay. Or I can go to Pune via any other path. Let us say right first to Kolhapur or Mahabaleshwar. Mahabaleshwar. And then I went to Pune. So my initial and final destination are same, but now I take a different route. Right? So I can go from one position to other position by taking different routes. These are my distances. Okay, so what is the distance? Distance is actual path length traveled or covered between 2 points. Okay. Without bothering about direction. What direction? We don't care about what direction we are driving. Like initially the direction was this way, then the direction changed, and the change, right? And then finally I reached B. Here also the direction is changing. So many times the direction is changing. So the actual path length covered, let us say is by this route it is 120 kilometers. By this route it is 150 kilometers. Right? So these are different path length to the same destination. I can have many more. Now what is displacement? There is something called as displacement. So between these two destinations, displacement is the shortest distance between the 2 points in a given direction. Now there is no change of direction, right? So it is the shortest distance between any 2 points in a given direction. Okay, so that is displacement. So it depends on direction, right? So in physics, we have 2 types of physical quantities, scalar and vector, right? So to describe distance can be described only with its magnitude, like 120 kilometer. No direction is needed. Such quantities are called scalar quantities. So distance is a scalar quantity. Scalar quantity. Right?
And what do you mean by scalar?
Yeah, that is it has magnitude only, no direction. Okay, like mass, time. These are scalar quantity. To describe mass or time, you don't need the sense of direction. If I say 20 kg, it will remain 20 kg in all directions, right? Time also, like 1 hour, 2 hour, you cannot associate direction with time. Whether you are walking in this direction, the clock will continue to move in one direction. Okay. So such quantities which can be described without direction, those quantities are called scalar quantities. Right? Whereas quantities like displacement, velocity, right? These are all vector quantities. So displacement is a vector quantity. Vector quantity. That is, it has both magnitude as well as direction. Direction. You cannot describe a vector quantity without also specifying its direction. Like when I say displacement, so I would say that this is 100 kilometers. And what is the direction? Along east. Let us say this is east direction. Right. So along east. So I have to specify direction also. Correct? So it is a vector quantity, that is, it has both magnitude as well as direction. Here, third, I'm just removing Mahabharata. We have written it down. So it is always positive. Yes. Scalar quantities are always positive. Non-zero. Or zero can also be. It is always positive. Now displacement can be positive, negative, or zero. Positive, negative, or zero. So let us understand it with the help of example. Can I erase the upper part?
Yes.
Consider a straight line path between A and B. Right? Consider a man starts walking. Right? Let us say this is at 50 meters and this is at 100 meters. This is 0 and 100. This is point B. Right. So the motion is like this. So A, B, C. Let's name this location as B, this location as C. So person walks from A to B, then from B to C. Okay. Then from C to A. Right? So these are three slots in which he walks. So what is the total distance covered? Is equal to. What is the total distance covered from A to C? There's a question. So it will be AB plus BC. Right? So this is how much? 50, this is 100, right? So this is 100 meters. First he travels 50, then another 50 makes 100. So total distance covered from A to C is this. Total displacement. Covered from A to C. What it is? Again, 100 meter towards or towards right. Right. So this is the direction. Towards right or east, whatever. You can specify direction the way you want to specify. Right? Or I would say plus 100. Then I would understand it is towards right. Did I write plus here? No, I did not write any direction. Now, distance in case of man walks from A to C and then returns from C to A, right? Total distance covered from A to C and back to A. What it will be? A to C is 100 and another 100. So this will be 100 plus 100 Okay, this is equal to 200 meter. So in distance, we actually take into consideration the actual path traveled. So this is 100 plus 100 equal to 200. Okay. So there are 4 different scenarios we have seen. So what is the total displacement?
At 200 meters towards right and left.
Placement from A to C and back to D. Means it goes from here to here and then comes back from here. So what it will be?
200.
A to C is plus 100. And C to B is minus 50. I said displacement you have to write this side. Plus this to the right. Now the is walking towards left, so direction is negative. So this will be plus 50 meter.
Then how do you
The way we have defined displacement. So displacement is the shortest distance between A and B. So this is displacement for all this. What is the final position B? Shortest distance between A and B is 50 meters. Then it is plus. That's what you have to keep in mind. How we define displacement. It is the shortest distance in a given direction between any given point. So it will be 50. How do we get it? 100 minus 50. So this is plus 100. This is minus 50. Because it travels in the opposite direction. So I told you, see the notes leftwards, direction will be, displacement will be negative. Okay. Okay. Now, one more question. Total displacement from A to C and back to A. What it will be? So this will be plus 100.
100 meters minus 100?
This will be 0. Got it? So this will be 0. So, I'm actually in a lecture. Yeah. So, right. Now suppose, let us say this is 0 and this side is 50. Let's say D. It goes beyond origin 50 meters in the direction towards D, right? So now I'm asking you one more question. Right? A to C and C to D. What is starts the motion from A, goes to C, and from C it comes back to D. What is it? Plus 100 meter minus 150, right? What do you get? Minus 50. Yes. So from here, the final position is minus 50. Now, do you get the sense of what is displacement? So displacement could be positive, negative, and 0. Now, what would have been the distance? It would be 250 meters. We'll add 50 more. For A to C and back to D, distance would be 100 plus 100 plus 50, 250. Got it? So this is the difference. So distance will always be positive. Now you see what we had written about distance and displacement.
Distance is positive. Diagram is magnetic. It is a scalar quantity.
Yeah.
And displacement can be negative, positive, or negative.
So we have seen all situations in a very simple example. So you can just make a note of it so that you will never forget. Done? Okay. So any questions here? So now we are going to learn about different types of motions. So uniform and non-uniform motion. So right now, uniform motion. A body is said to be undergoing uniform motion when it covers equal distances in equal intervals of time. Okay. Now suppose I can graphically represent it. So I will take x-axis as time axis and this as distance, right? So let us say it is x distance, x in meter, right? So let us say it travels and x meter. 50 meters. Here we have 1, 2, 3, 4, 3 in seconds. This. So let us say the body covers in every 1 second 10 meters. So in the first case, it will reach here. In 10 meters, then in 1 second, it will cover 10 meters. So in next 1 second, that is at when the total time is 2 seconds, what is the difference? It is still 1 second. Next 1 second, it reaches 20. So if you see the difference, 2 minus 1, 1 second. And here 20 minus 10, 10. So next second also it traveled 10 meters. Each second it is traveling 10 meters. Right? Each second it is traveling 10 meters. So this kind of a motion is called uniform motion. And when you plot a graph, the graph will pass through origin. Now this is origin, right? And it is a straight line, right? So uniform motion always has a straight line graph. X versus t, distance versus angle. So from graph also we can analyze the nature of motion. Next is, so you can draw the graph. Next, I will cover non-uniform. So here, straight line, uniform motion is a straight line. So you take any interval, say this interval if you are taking, how to figure out? So any interval you take, each interval, this is 1 second, and this is 10. Okay. So I can select any interval, like 2, 3, 4, 5. I will always see that in 1 second, 10 meters is covered. Okay. This is how you can analyze. So now for non-uniform motion, have you written this?
Yes.
Straight line graph.
Yes.
Right now, non-uniform. A body is set to be undergoing non-uniform motion. When it covers unequal distances in equal intervals of time. Okay. So will I get a straight line for non-uniform motion? No. So I get a curve. Okay. So it will be a curve.
It can also apply.
Sorry? Yeah, it could be anything. So it is not uniform, non-uniform. But up and down graph would be a complicated motion. We are saying like a body which is like speeding, first walking slowly, then running, jogging, running, right? So that is a non-uniform, right? So basically, what is happening? See, you can analyze on the graph. Let us say if I take this position, right? So in 1, 2 seconds, first, okay, here the first second, this is 10, so this is like 4. The first second it travels only 4 meters. Okay. Now in the second second, where has it come? Almost reached 10, right? So here it was 4, and here it is 10. That means it has traveled 6 meters. In the first second, it traveled from 0 to 4. In the second, see the graph, right? In the second, how much distance it has traveled? The last was 4. Now it has reached here. So when I project it is almost 10. So 4 to 10, that means it has traveled 6 meters. Now let's go to the next this thing. Where has it come now? Let's say this is 18. So now it is 8. Right? So which means in each second it is going on traveling more and more distance. So this is not uniform. The time interval is 1, 1, 1, but the distances covered are different. Got it? So that's why it is a non-uniform. Okay. So non-uniform motion. Graph is not, you say not a straight line. So first just this basic difference. Uniform is straight line, non-uniform motion is not a straight line. Right? And as we go further, we will actually talk about more difference. So how much more time we have? 10 minutes. So I think we can cover the definition of speed and velocity. Let us. Okay, can I erase the graph? Have you written this point? This is the understanding. Decrease it? Or switch it off maybe? So cold now. किसी बंद नहीं कर रहे हैं बाद में चल रहा है. Want me to switch off this fan also for some time?
Yeah.
I think the regulator is not perfect, so it's operates on this speed. Okay. So let's define what is speed. So these are various parameters, right, which are needed to describe a motion, like distance, displacement, speed, velocity. So what is speed? It is the distance covered distance covered by a body in unit time. Okay? That is speed equal to distance upon time. So what will be its unit?
Kilometers per hour.
Yeah. Or in SI unit, distance is meter per second.
Minus 1.
Because it is the denominator. No? So meter per second or meter per second. It's one and the same. Anything in the denominator when it goes up. Are you familiar with this sign?
No.
Okay, so you write meter per second like this. Yeah. Are you not familiar with this? 1 by 10 can be written as 10 to the power minus 1. No. So fraction where when the denominator goes up, right? It is written like this. So second goes up, it is written as.
So I can answer like kilometers per hour.
Depends in what unit the data is given. So hour in second is 3600 seconds, and kilometer in meter is 1000 meter. Right? So kilometer per hour is equal to 1000 meter upon hour is 60 minutes into 60 seconds, so 3600. Okay. So this is like 518 meter per second. So any speed given in kilometer per hour can be multiplied by 5 by 18 to convert it into meter per second. Okay. So 1 kilometer per hour is equal to 5 by 18 meter per second. So this is the conversion which you can remember. While solving numericals, it will be useful. Yeah. So, so speed we have defined. Now we have a concept of average speed. What is average speed? It is defined as total distance covered upon total time. Okay. Again, the unit will be same meter per second. So what is average speed? See, why do we have to define another quantity average speed? Let us say this is Mumbai, this is Pune. Let us say. Now from Mumbai to Pune, the vehicle will not travel at the same speed. No? Somewhere at signal it will be not traveling, so it is 0. Right? So it will travel with different speeds in different time zones. Yeah. Okay. So let us say here we traveled, say, let us say the total distance is 100 kilometers. So 25 kilometers, we have divided it into 25, 25, 25. So total distance will be 100. Let us say here traffic was less. Let us say full it took 4 hours. Right? So this was covered in 2.5 hours. Okay. This was covered in 1.5 hours. No. So let's check. Here it takes 0.5 hours. Here it takes 1.5 hours. Traffic. Okay, this is kilometer. This is hours. Now here it takes 1 hour or 1.25 hours. Right? And how much is remaining? Rest of the distance will be 0.75 hours. Okay, so what is the average speed? Average speed will be so it will be 0.5 plus 1.5 plus 1.25 plus 0.75 divided by. Oh, this is time, distance upon time. This will be denominator, right?
Yes.
What is the total distance?
Upon.
Total distance is 25 plus 25. Divided by how much is this? 0.5. So write separately, yeah? Don't be lazy.
Yes.
So that you understand what we have done. Because same distance took different time to cover.
Yes.
This will be like 100 kilometer upon how many hours? 4 hours. So this is like 25 kilometer per hour. This is the average speed we go. And if I have to convert it in meter per second, this will be 25 into 5 by 18 meter per second. I told you, kilometer per hour is 5 by 18 meter per second. So I got 25 kilometer per hour. So if I have to write the answer in meter per second, so I have to do this calculation. So I think we'll stop here today. The next class will be with velocity and a couple of other concepts. Any question? Just take a quick glance. No questions? Okay. So I think good for today. See you in the next class. Bye. Bye.